All right. Good morning to all the teams of Indonesia, and rather, I would say, congratulations. You have been shortlisted as one of the finalists of Indonesia Akruti 2025 finale. And we are going to start in couple of minutes. From our side, the juries are ready, the presentation is ready, the timekeeper is ready. So we will give another 2 minutes so that your other team members can join this meeting, and then we are going to start the event. Thank you so much. All right. So, good morning, all the teams, and good morning, respected jury members. I am Shubham Arora, and I am thrilled to welcome you all to the Indonesia Akruti Finale event 2025. Congratulations to all the teams on reaching the to this stage of the contest. And for the benefit of our jury members and for the students, I will talk about Akruti in brief. So, Akruti Innovation Competition is not just a competition. It's a launchpad for young innovators to apply creativity, technical skills, and teamwork to showcase to solve the real world problems. In 2025, the platform has expanded globally to more than 37 countries, giving all the teams an even bigger stage to showcase their talent and innovation. Akruti is not just a design challenge, but much more than that. It's a platform to spark creativity and build confidence in young minds. It's a platform which inspires students' innovation. Students noticed problems around them, big or small, and came up with the ideas that can actually help in accessibility, sustainability, health, or anything mattered to them. Akruti is about hands on learning. Students use SolveWorks and Dassault System solutions. It's the same tool which used by the professionals to turn their ideas into real design. We also guided them through webinars and boot camps to build physical skills, practical skills while working on their designs. And it is about giving students a stage. The winning teams from around the world will get a chance to present their work at 3D Experience World 2026 at United States in front of global industrial leaders. And that's a huge moment for any student. This year, we have had over 10,000 participants with representation from 37 countries. And this year is our 15th edition, and we have opened the doors even wider. Students from all the disciplines are welcome, whether it's engineering, design, architecture, business, medicine, or social sciences. Let's now dive into the exciting themes that fuel the ideas we celebrate today. These themes are carefully curated to bring out creativity while being kind to our planet, from innovative solutions that prioritizes health and well-being to designing spaces and infrastructure that are sustainable as they are livable, from harnessing renewable energy and improving its efficiency and storage to transforming how we move, we have it all. And as I have mentioned, students have undergone through these particular stages where they started with the registration and then they have prepared their product design. Then they submitted their initial design concept submission, and then at last they submitted final design concept submission. Our internal jury evaluation team has shortlisted the best teams from Indonesia, and here we are going to experience their presentations in few minutes. And the uh, teams who are going to win from this particular finale are going to move ahead for the EP South Geo finale round, which is going to happen on 9th of November. And we are going to share more details to the winners once we are done with today's round. And ultimately, the grand finale for Akruti International is going to happen at 3D Experience World 2026. It's in Texas, USA. Now, in order to evaluate all these presentations, we have an esteemed jury panel with us. So I would like to take some time to introduce Mr. Aid Ramdan, and he is currently a lecturer at Polytechnic Manufacture Bandung Polytechnic for Manufacturing College, and he has been involved into the manufacturing design and product development sector, including mechanical and tooling design for industrial applications and educative-based CAD/CAM implementation. He started career as a lecturer at Bandung Polytechnic for Manufacturing in 2002, and it's been more than 20 years now. He's actively involved in teaching, curriculum development, and supervising student projects in the field of CAD-based mechanical design. He's also experienced in using SolidWorks, Creo, AutoCAD for product and tooling design. He has participated in various national and international design initiatives and competitions related to mechanical design students. I welcome you, sir, for this Indonesia Finale event. Next, we have with us Mr. Johannes, uh, and his current designation is he's the head of tool making technology program from Astra Polytechnic. He has more than 17 years of experience. He started his journey as a junior instructor, and then it has led from chief instructor, lecturer, senior lecturer. Now he's an associate professor. Throughout the years, he has been consistent in technical drawings, CAD/CAM, and manufacturing efficiency areas. We welcome you, sir, for this Indonesia Finale event. Next, we have with us Mr. Mohammad Faza Firdaus, and he is currently a contractor in the mechanical design support at Multistrada Era, aka Michelin. He has more than 7 years of experience in assembly fixture, bolt cold forging die, safety instruments, general jig and fixture machines. He has started his career as a mechanical design engineer 7 years ago, and he has been supporting design for bolt cold forging die, assembly fixture for electrical power steering, SPM and die cast, shock breaker leak test machine, safety instruments, and SPM in the tire making process. We welcome you here for the Indonesia finale, sir. All right, so let's move ahead. There are certain instructions for the team presenters. We have already shared with you in their WhatsApp group. I would like to revise it again. Make sure all the team members, when we are calling a particular team, have joined the webinar with a good network connection. Be ready with your presentation and CAD model on your turn and respect the time limit provided for the presentation and Q&A. Be gentle while having Q&A with juries. Please make sure that only one team member is speaking at a time. You should not create any kind of chaos. Understand the question completely from the juries before answering it. And in case you don't know the answer, then politely pass by saying no or say, I don't know the answer. We are working on it. Presentation, you are going to take around 8 minutes per team, and for Q&A, jury members can take a total of 6 minutes, and you will receive one reminder from our timekeeper. Uh, Once 6 minutes are done, you will hear 2 minutes are remaining, and once 8 minutes are done, you will hear from our timekeeper, your time is up, and then we will move with Q&A, jury members Q&A. This will be the sequence for today's session. Initially, we are going to take 5 presentations and then we'll take a small bio break of 5 minutes and then we will join back again to have the remaining 4 presentations. So total 9 teams are presenting. Okay, I hope all set. And let me welcome our first team. Team Darnakel from Polytechnic Caltex Reau. The team ID is 1500701. And I would like to ask if the team member is ready. If they are ready, can you please unmute yourself and start your presentation? I guess your camera is inverted. Will you be able to change the camera position, team? Team, if you can hear us, your camera is inverted. Can you change the position of the camera if possible? Suraj, can you check with the team?
Yes, already checked.
Okay, perfect. Now, yes, it's good now.
Halo? Udah mulai. Oh, ini.
Team, please speak once again.
Can you speak once again, please?
Halo?
Okay, perfect. Your voice is audible to all the jury members, and the timekeeper is ready, and your time starts now.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, Honorable Judge, respected mentor, and fellow participant. We are from Darnakel team, from Polytechnic Caltex Riau. My name is Della, and then there was my friend Daniel, Haikal, and Adrian. And today, we're excited to present our innovation about comfortable wheelchair bed for enhanced patient mobility in a theme sustainable product for human wellness. Let's imagine if there was a patient who rely on bed and have a difficulty to moving, and also they need to go to bedroom. We, as a caregiver, need to help them. We lift them into wheelchair from the bed and going to the bedroom, and then lift them again into the toilet and doing it repeated again after them going to bed. What if the patient is so heavy and we are not strong enough or not have a nursing background? It will cause injury for both patient and caregivers. But let's imagine if there was an innovation that combined into a wheelchair and bed, and also the patient can do it independently when using wheelchair, and also design that suite into bedroom and toilet. After some research, we find that there were several innovations same like this, but still there have still weakness. For the example, design that are too large and not user-friendly, and then operate is still manual and cannot be used directly over the toilet. From that, we got some idea, and then we design and development this product to provide a solution that is safer, simple, affordable, sustainable, and give patient independence at the same time. It also have high potential market to hospital, clinic, rental service, and home care environment. Now, let's watch a short video that introduces our innovation. We design and development of a comfortable wheelchair bed to enhance patient mobility. In many countries, especially in Indonesia, many patients rely on wheelchairs. Moving from wheelchairs to bed is difficult, risky, and exhausting for both patient and caregivers. Also, patients often have difficulty going to the bathroom to defecate.
Our innovation is the comfortable wheelchair to bed. With a motorized frame, it smoothly transforms between wheelchair and bed. It can also move with patient control, giving independence and reducing caregiver workload. The system is powered by a rechargeable battery, making it practical and easy to use anywhere. Safety feature, manual and automatic modes, and an openable seat for hygiene make it highly functional and reliable.
This product fits hospital, nursing homes, clinics, private homes, and even rental services for short-term patient care. With the rising home care demand, the market potential is wide. Distribution channels include hospitals, medical suppliers, online marketplace, and government health programs.
Production cost is about 4 million rupiah with a selling price of 5,740,000 rupiah. After 11% VIT, profit is around 33,33% per unit, sustainable and profitable. However, this price may change depending on several factors such as raw material cost, component availability, production scale, and tax regulation. Wheelchair to bed, real innovation that empowers patients, disease caregiver, and creates strong business opportunity.
Team, you're on mute. Can you unmute yourself, please? Just change the setting on the Zoom. Unmute on the Zoom. Yes.
Let's
Yes.
continue with how our product works. Our comfortable wheelchair bed combines two essential functions, a wheelchair and a bed, into one innovation device. Designed with a motorized frame, actuator, and hinges, it allows a smooth and stable transformation between modes with just the press of the button. The product enables patients to move independently while ensuring comfort through its some aiding bed. In addition, there was featured an openable seat section to support hygiene and convenience, especially for long-term use. And then was a product design in openable seat mode, control button and motors, handle opening, panel box, and then was a product simulation. In your product reflection, how does it overcome the drawback of mission existing solution? Our innovation, combining two functions into one device, patient control and mobility, rechargeable battery, safety features, and improving hygiene.
In 2 minutes left.
In term of mechanical, in term of mechanical, in term of mechanical, we are using atas. In product design, we have component which is component mechanical RD. We have a DC motor and gearbox system for control of movement, limit switch for safety ensure and stop motion while fully transformed. A control button panel on the arms for patient operation, a microcontroller that process command and control the motor, a power drive circuit to regular current flow, and a rechargeable battery system. In product design specification, in electrical wiring, where there was a microcontroller that coordinates motor movement based on button inputs, a power driver circuit control the actuator direction and speed, limit switch ensure safety during transformation, and the battery and step-down converter provide stable power to the system. And also our product has static analysis factor of safety or VOS. We have in 4.1, which is it was so high and strong and safe enough for the patient, and also can lift patient in 100 kilogram. Also, in sustainability and impact, our innovation have a social impact in improving the quality of life for patients by giving them more independence of comfort while reducing physical strain or caregivers. In environmental impact, the use of rechargeable battery minimizes disposable waste and the dual function design reduces material usage. In economic impact, affordable to produce, it support home care accessibility and business opportunity in the medical equipment market. In business viability about cost effectiveness, if we compare about cost that we spend usually device or about our innovation, it's more provide when we are cost in our mind or our innovation. Why? Because our was flexible, cost effectivity, can use it independently, and then can control the wheelchair, and still useful, comfy but still useful. This innovation serves a solution to make things easier for both patient and caregiver. It offers the advantage of combining a wheelchair and a bed in one device. With adaptive design that can also be used in the toilet, it features an openable seat for hygiene and an electrical control system for wheelchair movement. This innovation also has strong business potential and probability, especially in the healthy market. As we know, the healthy business never ends. Thank you for the attention.
Thank you so much, team. That was indeed a wonderful presentation about your product that you have prepared. Now, I would like to welcome this floor to all the jury members. We can start with Mr. Aid, if you would like to have any questions or feedback for the team, and then we'll go with other juries. Thank you.
Okay, thank you, Mr. Subham. Great idea, I think, and very interesting to help sick people, right? Now, can you show us again how it move, how it animates the animation, how it transform from chair into bed again?
Yes, sir. Wait a minute. This one.
I see. So the middle part is for take to toilet, right?
Yes, sir.
Okay. Thank you. Great idea.
Thank you, Mr. Aid.
Yes,
Let's
sir. Thank you, sir.
move towards Mr. Mohammed. Mr. Mohammed, your voice is not audible. No, we can't hear you. Okay, while you're fixing your audio, let's check with Mr. Johannes if you have any questions.
Okay, thank you, Subham. First, I have to address my pride to young talented. Your real problem selection, it's very real problem selection. The problem is very real and impactful. Addressing patient mobility and caregiver strain, especially in home care setting. Uh, I need your explanation and have you have a professional comments or validation to this product?
So team, let me simplify it for you. Mr. Johannes is asking, have you undergone any kind of professional validation for your product? Have you checked with the required doctors or physiotherapists for this particular chair, whether it is really feasible?
Okay, sir. Let me answer the question. We also have coming into some medical center, and we just interview the nursings because we think that nursing is the most people that really have idea about what the product that we all have to do. So yeah, we are asking about the nurse, and then they said that it was uh, so hard if they have patient that heavy order them, and then they have to uh, lift them into the wheelchair. It was so it can cause some injury. That was that they say. And also we have he have to wawancara apa? We have to interview some patient and caregivers, which is it was our mentor. There he is a caregiver of his father. Yeah, he says that he needs that easy caregiver, but also can comfort the patient. And then there was my friend that have a patah kaki, broken leg, and he cannot walk for 1 month like that. And then he say that I don't want my mom or my dad is always help me because I need to going or I need to do it by myself. So maybe you guys can make some product that, yeah, it was comfy but for me, but it also can make me more independently moving when I need to go bedroom or I need to go to living room, like something else like that. Thank you, sir.
Thank you, Subham.
All right, Mr. Mohammed, do you have any questions? If your mic is okay now?
Check, is my
Yes,
sounds
we
clear?
can. Yes, we can hear you now.
Okay, team, I have a question for you. I just curious how you attach the when it's on the bed form into the bed. Can you explain to me how you attach your product into the bed?
Okay, so let me explain it. Let me open this video first. Was the simulation when we change into bed into the wheelchairs. We're using motorized and belt.
Yeah, belt.
Yeah, something like that, sir.
I mean, what is your method? How you connect the your product into the bed? Is it clear?
Oh, yes, yes. Okay, sir, I got it. Sorry, sir. Let me play this video first. Which is this? This is the video about it was with adding bed. That was our innovation. So we add some bed, and then we are making it more, or we can make it yeah, more flexible like that. So if we just using the wheelchair into the bed, it was not comfort for the patient because it was too small, and not good to make it to into the sleep. So we add some bed that still making the patient comfort. Maybe there was some thing that my friend will add.
So it transform between chair and bed. There was in the bed there's attach attach the back seat, so the back seat can save when it transform between chair and bed. Okay, thank you.
It's still strong enough, our innovation is still strong enough. Why I say this? Because in this adding bed, we add some hollow that can, if it is here. So was a hollow that can, what do you say? Hold the bed into the wheelchair. So it was still strong enough to the patient to
Also,
rely on this.
there is no connection. Just hold the bed.
Hold the bell. So there's no connection.
So Mr. Mohammed has asked, when you are connecting your wheelchair to the bed, are you making any kind of mechanical connection over there, or you are just keeping it like that?
Yes, right. So
Oh.
you have like a bolt
It's
connection
depend.
or just
Thank you for
clicking
the question,
connection?
sir. Let me explain. So because it was a wheelchair, can we can control it by ourselves because there was electrical system on it. So when we after going the bedroom and we need to go to the bed and we have to park the wheelchair on into the adding bed by itself or helped by caregivers too.
So you don't need to put any kind of bolt connection. I mean, what if when you are parking your wheelchair over there next to the bed, it can move, right? Because it has wheels. Have you put any kind of stopper or something like that which can keep your wheelchair stop? That was a question by Mr. Mohammed. I mean, it can slide away, right? When you are parking it.
We have ini nggak sih Kak, apa pengunciran itu? Siapa yang
Okay, sir, thank you for the question. I can answernya. The wheelchair is connect to bed from inside have a hollow still form make me chair is not moving around this,
Okay, okay. So you
and
have,
motor
yeah,
is locked moving for because motor have a gearbox and rotation is not moving around to the bed
okay,
uh,
okay,
if wheelchair off.
okay, okay. I hope the students have answered your question, Mr. Mohammed. All right. Thank you so much, team. No more questions from the jury members. That was really a great presentation from your team. And thank you so much. And jury members, you can take your time to evaluate the scoring sheet. And meanwhile, we will check with our another next team, which is, let me share my screen. So moving ahead, we have our next team presentation. The team name is DTech Pyro Fuel. The team ID is 1500686. Jury members, please take a note. And the college is, I don't know how to pronounce it, Garja Mara University. So I hope if the team is ready, they can raise their hand so that we can invite you as a panelist. And for all other teams, now you know how the presentation have been done. The first team has already set a great benchmark. So make sure that you are preparing and you are giving your best in front of jury members. Okay, any team member from Team DTech Pyro Fuel, please raise your hand so that we can invite you. I have promoted one student, Christian. Any other team member from this team? Please raise your hand. There's an option over there. Okay, so they have joined from one system. Okay, perfect. So Team DTech, now you can share your presentation. I will stop sharing my screen.
Hi, good morning, judges and everyone. Every day we use plastic bottles, bags, and food wrappers, but most of them don't disappear. They end up in landfills and ocean, taking hundreds of years to decompose. Millions of tons enter the sea each year, harming wildlife and even us through microplastics. This is not just a waste problem, it's an energy opportunity. So, our team aims to turn plastic waste into clean, usable energy, and that's why we call our project Turning Plastic Crisis into Clean Energy Opportunity. So, let me introduce ourselves. We are the Technology M from Gajah Mada University, presenting our innovation, the tech power fuel for green energy generation, transmission, and storage. Guided by Dr. Engineer Yusepus Ardean, our mission is to transform plastic waste into energy through a compact, automatic production system designed for community and household scale use. Global plastic Global plastic production keep increasing, yet most plastic are non-biodegradable. Improper disposal leads to landfills overflow and ocean pollution, while traditional methods like burning or burying are inefficient and harmful to the environment. This situation demands a clean, small-scale waste-to-energy solution that can be implemented directly within communities. We identified three key problems. The first one, ineffective disposal method that create pollution. The second one, poor waste management system in developing countries. The third one, lack of accessible technology to turn waste into usable energy. So our answer is mini pyrolysis system, not a large industrial kind, but a compact and automated version that communities can operate safely and efficiently. These projects have reduced pollution, decreased fossil fuel dependence, and support the circular economy. In countries like Indonesia, where waste infrastructure is limited, a household scale pyrolysis system provides a practical, low-cost, and eco-friendly solution that empower people to manage their own plastic waste while generating energy for daily needs. So, research shows that plastic pyrolysis can convert 22 to 25% of waste into liquid fuel and reduce carbon dioxide emission by up to 40% compared to open burning. Based on this, we designed a mini pyrolysis system with integrated automation, featuring automatic temperature control and monitoring, compact modular design for easy maintenance, and syngas reuse for internal heating, reducing external energy use. This innovation creates a self-sustaining small-scale waste-to-energy units suitable for communities and households. Our research focused on LDPE and HDPE plastics, which are common in daily waste and ideal for pyrolysis. The dual reactor design with two-stage condenser maximize oil yield and efficiency. Meanwhile, the PID-based temperature control, safety locks, and emergency shut-off system ensure stable, safe operation. In essence, the system is smart, efficient, and safe enough for household-scale implementation. Technically, the system offers real-time monitoring, temperature stability, and modular design, make it easy to assemble using locally available materials. Economically, with a capital cost of $3,100 and annual profit of around $1,700, it provides a payback period of only 1.8 years. Environmentally, it reduces emission, support renewable energy transition, and empower local communities to manage their waste sustainability. In short, our innovation is viable, affordable, and impactful, a true community-based clean energy system. In the next part, we will show you how our final system design, a compact automated household scale pyrolysis system that is efficient, safe, and ready to make a real impact. And this is our final 3D CAD design of the mini pyrolysis system. It consists of mechanical, electrical, and process components. The mechanical parts include the reactor, condenser, and frame, where the plastic waste is processed. The electrical parts, such as control panel, water pump, and safety button, help with the automation and temperature control. Our system uses heat-resistant and corrosion-proof materials, such as stainless steel and copper, to handle high temperature up to 100 degrees of Celsius. It is easy to operate, require only 1 or 2 users, and has an ergonomic control layout for safety. The design focuses on efficiency, low cost, and reliability, supported by automatic control and good ventilation.
In 2 minutes left.
Our journey began with a simple question: how can we turn the plastic waste problem into something useful? From identifying the issue of unmanaged plastic waste, we found pyrolysis as a promising solution. Then we developed it into a mini automatic pyrolysis system that works at a household scale, small, efficient, and safe. This innovation proved that with the right design, plastic waste is not the end of the material's life. It's the beginning of new energy. Thank you. Do you have any question? For the judges, is there any question for us?
Yes, thank you so much, team. That was a really wonderful presentation. And let's move ahead with the jury Q&A. And now let's start first with Mr. Johannes.
Okay, thank you. Our friends from Gajah Mada, it's very good idea and very real problem selection you have provided. I want to ask you about as we know, within the years, the circular economic is getting popular. If this product is produced, who will be the users of this product? Who will be the user of this product? And the second is, what is the public opinion to your products? This is my two question.
Okay, thank you, Mr. Johannes, for your question. So I will answer the first question. If the product is produced, who will use our product? Uh, so the consumer of our product will be the household. Um, uh, will be the,
Okay, thank you for your question. I will answer it. So our product is for household use. So we highlight the mini pyrolysis. So mini and is not for industry. So it is only for household. So it's mini and many people can use it. And also we give it some automation with the control panel and something else. So many people in the household can use. So, and then the second question, we saw many videos about that pyrolysis on YouTube, but most of them is not for household. So most of them is maybe for some industrial or some company to throw their trash or garbage. So we made the mini pyrolysis, and also in our environment, it can be useful because we are near from the garbage from the garbage place, and yeah, we think it's so useful for it.
Thank you for the answer.
All right, let's move to our second jury. Mr. Aid, if you have any questions.
Yes, thank you, Mr. Shubha. Uh, Dear colleagues, very good presentation and interesting concept. Could you please show us the outer dimension of your system and explain where it would be most appropriately located in our house? Something like that.
Dimension, process dimension.
Thank you.
Okay. Thank you, Mr. Ade, for your question. So the dimension of our product, it's the height of the product is around 1.5 meters, and the length of the product is around 3, and the length of the product is around 1 meter. So this product can you can place it in the backyard of your home, in the town hall, or of the uh, village meeting hall, or something like that.
Yes, thank you.
All right, moving to our last jury member, Mr. Mohammed, if you have any questions or feedback for the team.
Okay, thank you. I think the paralysis method is like the general that we all know. Maybe I want to ask you guys about, can you show me the box that that your function is to throw away your waste?
I'm sorry, sir. What is your question? I'm sorry.
The box in the bottom
Oh, the box in the bottom is
for your wax.
Thank you for your question, sir. The box in the bottom is used for the coolant.
Oh, you will put it away to throw away your waste, right?
Yeah.
My question is, how you take away that box from your frame? Is that any space for maintenance to reach that box easily?
Yes. From the behind of the product, you can easily remove the box. So there's enough space to remove the box from the behind.
Can you show me the behind side?
Uh,
Because if I'm not mistaken, I saw one frame that that will be have an interference with the box.
I'm sorry, can I share screen the SolidWorks?
Yes, you can share. Please go ahead.
Okay. Yeah. Ouch. Yes, I'm sorry. It's not from the behind. It's from the side of the product. You can remove this box from the product.
From that side?
Yeah, on the left side.
Okay. Yeah. My advice is just make sure that your width of the box is can put away from that frame. Just because I think that's too big. That's it.
Okay.
Yeah. Thank you.
Okay. Thank you, Mr. Faza, for the advice to our team.
All right. Thank you so much, team, for this amazing presentation and wonderful Q&A. Now let's move towards our third team. And meanwhile, I request jury members to provide the evaluation for this particular team. This is DTech Pyrofuel. Moving ahead for our third team, the team name is Anno Brain Electric Vehicle from University Singapore Karawang. The team ID is AG25150013990. So requesting the team members to raise their hands so that we can invite you as a panelist. Okay, I can see the team members have joined already. Perfect. Team, whenever you are ready, let me know. I will stop sharing my screen or you can start sharing your screen so that we can test once. Perfect. We can see your presentation now.
Okay, ready, sir.
All right. Perfect. All the best. Go ahead.
Good morning, honorable judges and audience. Thank you for the opportunity. Allow us to begin our presentation. DG25 1500139, Anugerah EP, University of Singapore Bangsa Karawang. Greetings to the judges and innovators from around the world. We are Team Anugerah EP from University of Singapore Bangsa Karawang, Indonesia. Our project focuses on sustainable mobility, integrating renewable energy and eco-friendly materials with digital, solar and wind charging system for EV with pineapple fiber composite body. This is our team Anugerah EV and our mentor. Global warming is increasingly threatening our aging planet. Environmental pollution continues to worsen due to dense industrial manufacturing, especially in the transportation sector, combined with air pollution from fuel ash. Also, the shift toward electric vehicles has begun. It is not yet the ultimate solution. What we truly need is green energy. We call this concept the triple win solution. Vision to protect the environment from carbon emission, empower local farmers through the pineapple fiber supply chain, and promote a green economy through sustainable technology. According to the Journal of Cleaner Production 2020, the transportation sector contributes about 24% of global greenhouse gas emissions, much of which come from fuel combustion in vehicles. In addition, Ma'arif Anjani and Santoso 2023 stated that pineapple fibers, which contain 70 to 80% cellulose, have great potential as an eco-friendly composite material for vehicle bodies, which are liquid, strong, comfortable, and capable of increasing the economic value of agricultural waste. Imagine a vehicle powered by clean energy capable of charging itself intelligently. According to Prajapati NPS 2023, a hybrid charging station by solar panels and wind turbines can help reduce carbon emission and lessen the load on power grid. This is our concept, Anugerah EV, a lightweight electric vehicle made of pineapple fiber composite body with a hybrid charging system powered by solar and wind energy. Here is the final embodiment of our dream, Anugerah EV, a futuristic electric vehicle born from the fusion of technology, nature, and sustainability awareness. Based on our analysis using the adjust material, the total vehicle mass is approximately 177 kilograms, showing both material efficiency and design suitability for a liquid EV. The body is pineapple fiber composite, while the chassis is made of high-quality steel to maintain structural strength. The hybrid charging system combines solar panels and wind turbines as renewable energy source for the vehicle. The solar panels generate direct current, while the wind turbine produces alternating current, which is force converted into DC through a rectifier. But DC output are then transferred to the maximum power point tracker, which optimizes and balances the power generated from both sources for maximum efficiency. From the MPPT, the regulated power flows to the main storage battery, which functions as an intermediary energy bank. The stored energy is then supplied through the charging port and finally delivered to the EV main battery system, powering the vehicle motor. This integrated setup allows the system to utilize solar. Sustainability lies at the heart of Anugerah EV design. We focus on long-term ecological, social, and economic impact. The combination of solar and wind energy reduces carbon emission, while pineapple fiber replaces non-biodegradable synthetic materials. This project also empowers farmers increases village income and raises awareness about the transition toward clean energy. We aim to build a green mobility ecosystem that is environmentally friendly, community-driven, and strengthens the local economy. After conducting stock analysis and calculation, the total estimate cost of producing the unbranded EV prototype is between 5,700 until 7,600 USD, with an additional 1,300 USD for the hybrid charging system. The total investment ranging from 7,000 to 9,000 USD reflects a design that is efficient, realistic, and ready for further development. After viewing the technical design, simulation, and business feasibility analysis of the unbranded EV, we invite you to witness how we bring this concept to life in a concrete visualization. This is the unbranded EV, a vision for sustainable mobility.
Team, your sound is not coming. I guess you have not turned on your sound when sharing your screen. Can you stop sharing and
Okay.
share it again and then use the share sound button?
Okay, please wait, sir. And
Yes.
sorry.
Just press escape. Go back. Stop sharing your screen once. Okay, now click on the green button, which is share button. And when you click on the share button, on the right side, you see share options, and there's one option called as share sound. Just click on that and then click on your presentation. It will play your video with audio. Team, any issues you're facing, please let me know. Are you clicking on share sound option, please? Have you checked the WhatsApp group? We have added a screenshot over there. Just check the WhatsApp. There's a screenshot how you can share your sound. If the sound is not relevant, that's okay. You can still play it. Otherwise, you are losing your valuable time. Maybe you can explain when the video is going.
Okay, please wait, sir. Sorry.
Coba.
That's okay. Continue the video without video.
Okay,
No problem.
lanjut.
No. Continue.
Indonesia produces over 40,000 tons of pineapple waste annually. According to the video plan, much of this is burned, adding to pollution of compost body with a renewable charging system, biogas panels, and a hybrid wind turbine. Zero grams of CO2 per kilometer, and empowers local farmers on a sustainable supply chain, designed to be light for everyone.
Thank you very much and attention, honorable judges. Now switch into the Q&A session. We will be happy to answer your question and receive more insights about our innovation.
That was a great presentation by team. Thank you so much. And moving to our jury's Q&A, we can start with Mr. Mohammed first.
Okay, thank you. Okay, team, I think the pineapple fiber itself is already a great idea, and you guys make a idea for make a EV. It's a great idea, but maybe my question is, did you have a data for how long that the vehicle, that the car can go, just in case to know what is function in the society? Maybe this my question. Thank you.
Okay, please wait, sir.
Okay, let me answer that question, sir. To 15 to 25 kilowatt hour, that's for 15 to 25 kilowatt hour, that's 75 to 165 kilometer. Thank you, sir.
Okay, thank you.
All right, moving to Mr. Johannes, if you have any questions.
Okay, thank you for great presentation. This project stands out for its holistic approach for sustainability. This product is very interesting since it has social, economical, and environmental impact. But we also have to make sure about the safety. My question is, the first is, have you validated the crash safety of the pineapple fiber composite? Yeah. Have you validated the crash safety of the pineapple fiber composite? Or have you compared your pineapple leaves with other composite? That's my two question. Thank you.
Okay, thanks for your question, sir. We conduct stands. Okay, we select pineapple leaf fiber because it offers a unique combination of strength, lightness, and sustainability. For mechanically, its tensile strength range between 100 to 180 to 250 megapascal with a density of 1.2 gram per centimeter cubic, about 30 to 5% lighter than fiberglass. For environmentally, it utilize agricultural waste from local pineapple farms, turning organic waste into high-performance composite. For socially, it empowers rural farmers by introducing a new value chains in green manufacturing. Thus, this choice bridges material science with social innovation. Thank you, sir.
My question is, have you validated the crash safety of this pineapple fiber composite? Okay, if you have not validated, it's okay. It's my question. Thank you.
All
Okay,
right.
sorry, sir.
Mr. Aid, if you have any questions.
Yes, thank you. I think you you have done a very good concept and a very detailed design. What I saw in the presentation, also in the PPT. So I just want to confirm once more. Could you please show us which part of your product use the most pineapple fiber and explain why it is use a pineapple fiber? Please.
Okay, please, sir.
Okay, thank you, sir. This is the result of the fiber from the pineapple leaf for body car, electric vehicle.
So the body is the most using pineapple fiber, right?
Right, sir.
Okay, thank you. Thank you, Subham.
All right. Thank you so much, team, for this amazing presentation and Q&A. Let's move ahead to our next and the fourth team, which is Team Polytechnic ATMI Suryakarta. Okay, the college and team name is the same. Team ID is 1500569. So team, if you are available, kindly raise your hands so that we can add you as a panelist. Jury members, meanwhile, you can put your evaluation score for the previous team. Team, let us know once you are ready. You can start sharing your presentation and then I will stop sharing mine. If you are sitting at the same location on different devices, make sure that you are keeping your one speaker on, which is audio, so that we don't hear any echo. Okay. So you listen to one device and you speak from one device, something like that you can do. But you can keep your videos on. That's okay.
I'm sorry, sir, but in setting we cannot play the sounds from the Zoom.
Any issues?
Yes, we have an issue that we cannot play the sound from the Zoom setting. It's cannot be played.
Okay, no problem. So when you are showcasing your video, if there are any wordings which is running at the back end, you can explain in your own voice. That's okay.
Okay, sir. Thank you.
Yeah, thank you. Okay, you can start whenever you can. Just put your presentation in the presentation mode. All right, perfect. All the best. Go ahead.
Okay, good morning everyone. We are from Polytechnic Admi Surakarta with team ID AG2515000569. And today we are excited to present our project with title Modular Adaptive Food Preparation Board. Our team consists of Firdausa Aditya Bhakti as the leader, Andika Prasya Nugraha and Metuli Masaputra as designer, Evan Kumara Yuda Pratama as brainstormer, and our mentor, Mr. Fidelis Gigi Triatmaja. This project was developed under the theme Sustainable Product for Human Wellness. The first one is background and problem from our product. People with head disabilities or injuries struggle with basic cooking tasks, such as cutting, peeling, and chopping. This results in depend on other reduced independence, confidence, and emotional well-being. Studies show hand function loss affects self-esteem and social participation. Based on the above, we conclude that what they need is an adaptive kitchen tool that allows safe, easy, and one-hand food preparation.
Okay, the next one is solutions. So our product is modular adaptive food preparation board, and our key feature is a strong clamp and quick release system, non-slip surface for stability, slicer for three changeable blades, and also food pusher. And also for the base, we use recycled plastic from bottle caps to make the base, and to prevent the microplastic from exposure, we coat the base with a food grade coating. And also for the all material that we use, we're using a stainless steel SUS 304. And with this product, it can accommodate 40% of the total 100% cooking process. And the next one, we're going to play videos. So this is the modular adaptive food preparation board that we've been make.
Okay, so for this design, that the first one we have a camping device in here. The second is one manual chopper. The third one is a slicer and slicer press. The fourth one is a pillar. And this is how the clamping device works.
All right, we are going to advantage and innovation. The first one is one-handed operation. So in the one-handed operation, this is for people with limited mobility, especially disability with one hand. And then multifunctional use. So multifunctional use is slicing, chopping, and clamping. And then ergonomic and stable. So our product is easy to use, especially for one hand disability, and stable. So in the stable, our product is have anti-slip fit. Therefore, when operator or people cutting in the our product or chopping or something, it will stable. And then modular design. So modular design, our modular design is easy to clean and easy to maintenance. And the last one is eco-conscious. Eco-conscious is so several of our part product is made from recycled plastic, especially HDPE. So above all, it's combines social inclusion, sustainability, and practicality. And then we going to impact and sustainability. We have three impact and sustainability. And the first is impact, environment impact, and the last is economic impact. In the social impact, first one is promoted independence and inclusion for users with hand disabilities. And second is reduce reliance and caregivers. And then we're going to environment impact. And the first is use recycled materials. And then second one is non-electric. In the economic impact, production cost is 35 to 39 US dollar. And the selling price is 52 to 55 US dollar. And the ROI is 33 to 54%. From our research, there is strong market potential for inclusive and sustainable kitchen tools.
Team, 2 minutes left.
And then we're going to sustainable development goals, or we can call it SDG. So we have 5 SDG, and the first one is SDG 3, and that is good health and well-being. And the second is SDG 8, that is decent work and economic growth. And the third one is SDG 9, industry, innovation, and infrastructure. And SDG 10 is reduce inequalities. And the SDG 12 is responsible consumption and production.
Okay, conclusion and future direction. Module preparation board, an inclusive, eco-friendly, and partial kitchen tool with comprehensive feature. Our product has several key features that make cooking easier for one-hand user. The first, the clamp and quick release work like a movable clip that securely hold ingredient in the place. Next, we have the slicer, help us hold and cut food safely and evenly. Then, the peeler makes peeling much simpler and safer. The food feeder, the manual chopper, allow easy chopping just by pressing the tab button. Lastly, the set knife is ergonomically shaped to make cut more efficient. Altogether, this feature provides safe partial and independent one-hand cooking. Helps one-hand helps one-hand user live more independently. Simple design, big impact for everyone. Thank you for your attention. We hope our innovation can inspire others to create more accessible and sustainable solution for everyone. Thank you. Additional reference and supporting materials can be accessed through the QR code below. Okay, we'll return the time to the moderator.
Thank you so much, team, for this wonderful presentation. You have actually picked a very good problem statement, and definitely, I guess no one is working as of now on such kind of products. So I let jury members to take over now. Let's start with Mr. Aid first, if you have any questions or feedback.
Okay, thank you, Mr. Subang. Guys, this seems like a valuable tool, I think, for people with disabilities. But you say it's easy to clean. So can you explain to us, do you have any idea how the equipment, slicer, chopper, and so on could be cleaned easily? Do you understand?
Yes, sir, I understand. Thank you for the
Okay,
questions.
please.
So the chopper, which is the knife, it is inside the bowl, and we can take it off from the bowl and we can wash it regular things, like a knife and other things. And for the slicer, it's movable, so we can just pull the knife and we also can clean it. And the base also is movable too, so we can move the base from the plastic base. It's wood.
Okay, that's all. Thank you.
Yes, that's all.
All right, thank you, Mr. Aid. Let's move to Mr. Mohammed.
Okay, thank you. Okay, team, I have maybe a several question. My first question is why you don't have a special place, special box for the knife, for knife and what is called? Yeah, the two knife. The second question is for the slicer. Are you use the general slicer like there is already available in the market, or you make again by yourself? And the third question maybe why is your knife have a shape like that, not use a general knife shape? Maybe that's it. Thank you.
Okay, sir, thank you for your questions. I'm going to answer your first question first. Unfortunately, yes, we don't have any design for put our knife yet, but we're going to that after this. And the second one, yes, some of our parts is aftermarket. Let's say from the chopper, unfortunately, the chopper is aftermarket, and we modified parts and some stuff. And for the slicer, the aftermarket is only the knife, and for the board and rest we make it our own. And for the third one,
Okay, I'll answer the third one question. Why the shape of the knife is different like usually. So we are modifying the knife for comfortability to one hand disability. So when we looking for usual knife, it just strike. So we should modify that have angle so disability can use it easily like that.
Okay, maybe one question more, a little bit, just a little bit question. Following the Mr. Ade question, I also curious, what is the weight of the table?
okay, for the weight of the table, it's not more than 2 kilos, because well, it's made from plastic materials, HDPE, but it's a light, not that heavy. Because some of point there is a hollow in here under the slicer. It's a hollow thing, so it's not that heavy. Maybe kilos, not to up to 2 kilos.
Okay, thank you, team.
All right, let's move to Mr. Johannes if you have any questions.
Okay. The modular preparation board is a thoughtful and inclusive innovation. I think it's in line with your tech, namely meant for others. Yeah, your tagline. Have you do a trial or usability testing across the different disability types? And my second question is, how unique of this product? I mean, it's a completely new product or it's a modification of an existing product? Thank you.
Okay, sir. Thank you for the questions. So, well, basically, this is a modification of the existing Spark product. There's already been in the market that a modular adaptive food preparation board that for disabled, it's already in the market, but it's very expensive and it's not available in every country and it's expensive. Basically, it's that. And we been make a prototype, but unfortunately we don't bring it today here. But we test it with ourselves. We put one of our hand in our back and try to make it, because basically this make for one hand food preparation board. So we just use one hand to operate it. It's either left or right hand that we use. Thank you, sir.
Okay. My last question is if you have concern about the price. I mean, you find that the price is higher in other countries and also in Indonesia. What's your opinion about your cost? Your price is, if I'm not mistaken, about 50 or 55 US dollar. Is right?
Yes, sir.
Is it affordable for your disability environment?
Well, in another product, it's been sold for $100 or maybe more, sir. And we use recycle, so we can push it to more cheap price for the people for buy it and use it. Because the first our costing is based on Indonesia rupiah for the first time, but we converted to United States because we've been thinking that our uh, problems is in Indonesia. So we've been looking for another stuff that, yeah, that the price of 52 to 55 US dollar is affordable for people. Then you must spend $100 or maybe more just for the same stuff with less than things. Sorry, that's it.
Yeah, maybe you should have a charity to make the prices lower and lower. Thank you,
Yes.
Subham.
All right, thank you so much, jury members, for this wonderful Q&A, and thank you so much for team for this amazing presentation. Jury members, please make a note. This is the fifth team, not the fourth one. Now I'm going to introduce the fourth team, which I skipped earlier. So meanwhile, you can provide the evaluation sheet, the marks accordingly for this particular team. This is the fifth one from Team Polytechnic Suryakarta. Okay, now let me invite our next team, which is Bio Rubbish Ranger. The team ID is 1500904 from Polytechnic Caltex Real. So team, please raise your hand so that we can invite you as a panelist. This will be the fifth last team before we take a bio break. So anyone from Team Bio Rubbish Stranger, if you are available, kindly raise your hand so that we can promote you as a panelist. I don't see anyone raising hand. Okay, I can see one member. Let me promote him to panelist. All right. So Daniel, are you the only one who is joining? Daniel, please unmute yourself and speak. Hello, Daniel, if you can hear me. You can unmute yourself, please. Press escape if you are not able to see your settings. Okay, yes, Daniel, can you unmute yourself? There's an audio button you can just select. Yes. Can you speak
Wait,
now?
sir. We have a problem here.
Okay. Can you let us know what's the problem?
The camera cannot to open.
Okay, no problem. I guess there might be some challenges there switching on the camera. No worries, you can start your presentation. I was asking if there are any other team members who are also joining, or all the team members are together right now. Sorry.
Shubham, I guess they all are together. They have texted that they have one camera, phone, and one laptop with them.
Okay. All right, team, whenever you're ready, you can start your presentation accordingly. Currently, we can see a smaller screen. Can you put share screen on a different slide? Because we can see your different screen right now. Suraj, can you take a screenshot, send them a WhatsApp message? You need to
Yes.
change, yeah, you need to change your screen presentation, Daniel.
It's a presenter view which we are able to see.
Yeah.
Yeah, it's
Ya ada kan? Oke, nampak belum?
Yes, perfect. We can see your screen. Okay,
Hello,
go ahead.
ladies and gentlemen. We are Biora Stranger from Polytechnic Caltex Riau. We want to presentation about design of small-scale real-time distribution unit for household application. I am Ahmad Daniel. I am the team leader. This is our mentor, this Mr. Wigianto.
Problem description: accumulated garbage causes disease and environmental pollution. This is a picture of garbage in Pekanbaru. Next. Green energy generation, transmission, and storage. Because we aim to create eco-friendly fuel in a smart way by turning household waste into a useful source of energy instead of just trash.
Okay, this is urgent. This is because cause air pollution and spread disease.
Our solution help protect health and keep the environment clean and safe. Next. The research show that household waste is abundant and easy to collect. This device reduces fruit and vegetable waste, keep the environment clean, and the prevent bad odors and diseases. The bioethanol produced can also increase family income. Next. And this the final solution and innovation. Our machine is small and compact, perfect for household use. It can process up to 16.23 kilograms of organic waste per cycle, producing bioethanol with economic value. It's eco-friendly, runs on electricity, easy to maintain, and suitable for both home and small-scale industries. Next.
As you can see, this is our design for bioethanol distillation unit. This machine used 4 tubes. The first is chopper tube. The second is fermentation tube. The third is distillation tube, and the last is the ratio tube. And the process for this machine is chopper the waste into sludge, then it fermented by maintaining a temperature 35 degrees Celsius for 24 hours. After that, the distillation process use cold water. Finally, it collects the final product in the last tube. And this is for specification.
So this is a product reflection where the problem inspiring our innovation is organic waste from the fruits and vegetable that is a major issues in market and household that accumulate organic waste produced. And second is accumulate waste release maintain gas that contribute to global warming. And next is our bioethanol machine convert waste into renewable energy and liquid compost. And the green economic value that can make income generation from potential for market operator, waste cooperative, and renewable energy SEMS, so bioethanol cells and compost production. And then we can make create new job opportunities in organic waste collection, machine operation, and of bioethanol and compost marketing. Next. And this is our process design. Start with great ideas, then needs analysis, research, literature study, design the machine concept, and concept concept evaluation, and finally concept technical design. Next. This is our impact of our solution, that our machine convert household waste into bioethanol that from leftover fruits and vegetables. We make it to bioethanol fuel and liquid compost. And from then we can make reduce amount of waste and make a more cleaner environment. That's support cleaner environment and green energy. Next. And this is our business viability that we make some application in our city, Pekanbaru city, that Pekanbaru city can produce about 1,500 kilogram household per day. That's requiring economy that we need 70 units machine to produce this 1,500 kilograms to make compost and bioethanol. Then we can make that bioethanol and compost to some money. That total of the value we can make from that vessel is 26 billion and 560 million rupiah, and we just only use 70 machine that about 1,995 billion rupiah. Next. And this is our journey video that we make how we make inspiration from our machine.
2 minutes left.
So
as we know, household waste is a problem because few people process. Instead, this waste is often concentrated trivial because it's small. But if collected, it can become a lot waste. So we should to have this machine because this waste can cause air pollution and cause disease. So we are going to some market or to household or the house. We looking for the household waste. So as we can see, sorry. So when I go to market or go to the house, I can see the lot of waste hall. And when I uh, question to other people, what are you doing for your household? And they say, my household waste is just to to trash bag. So I think it's the good, so it's the bad idea. So we are the representative come to make bioethanol fuel from household waste. Okay, we have four we have a four design. So the design is as we choose is the design for me.
next.
Okay, that's all for our this presentation.
All right. Thank you so much, team, for this presentation. And let's start with our jury Q&A. Let's start first with Mr. Johannes.
Okay. Bioethanol production is a known concept, but applying in at household with compact module designs adds a layer of originality. Please let me know how unique is this product.
Okay. This machine is unique because it's just a compact size. And we can produce bioethanol and compost from
Okay.
the waste.
Okay. From your description, you say that fermentation time is 48 hours. And then it convert from 16.24 kilograms into 0.95 liters of bioethanol. Is right?
Yes, sir.
Yeah. What's your idea to solve this limitation? You need to this to convert 0.9 liter of bioethanol. What's your idea to solve this limitation? Okay.
Okay. Our idea to our solution from that emission limit is we have to put some more like chemical for the fermentation to be much faster than usually, and we have to make the chopper mechanism more faster, so the waste hole can be much smoother.
And then what's the impact? The bioethanol production is higher or fermentation time is getting long?
What the impact of that, what I say before is the fermentation can be much faster than before because the smoother vessel after choppering can be much faster. The fermentation can be finished.
How fast the reduction time? How short the reduction time? From 48, what's the new time? Getting half or faster?
Okay. How faster that impact will be after we searching about journal, some articles, the smoother that vessel can be, it can be more faster about 5 hours. So not 5 hours, 24 hours faster. That that's impact about the smoother of the vessel.
Okay, thank you.
All right, Mr. Mohammed, if you have any questions.
Okay, maybe my question is from the transmission area. That make me curious. My first question is, can you explain to us why you consider, what is your consideration to have a bevel gear instead of you have a direct connection motor into the cutter? The second question is, for the bevel gear, did you need lubrication or not for that transmission? Because that is only the bevel gear in your 3D model. And what do you think about the safety of the transmission? Because I think if you put this in like for household, maybe that people hand can reach that transmission and causing that can be destroy your hand. Maybe that's all. Thank you.
Because it's the simple transmission. For the
Transmission from the motor to
I think it's the best. I think it's the best design. So we choose the bevel gear for this transmission. So about the safety, I think we should some cover, next some buffer. So for the filter design. It's very common and we have the cover to protect from our hands.
Sorry, what do you have for protect the transmission for the hands?
saya bisa dari putar itu menutup mata.
If there is no protection, it's okay to say no protection.
Jadi di sini okay, actually in this design we not put some cover to make these machines more safety, because this we want to show how the mechanism and how we put the part in the design, so anyone can see the part with more yeah. We want to show the whole park without the cover.
If you say so, you have also a cutter that inside the box and we still can see it. But yeah, anyway, I understand your explanation. It's okay. Thank you.
Okay, thank you, sir.
All right, Mr. Aid, if you have any questions.
Yes. I think the product appears to be very effective in reducing waste, and it seems feasible for real use, but I still don't I want you to explain again how it works from the moment operator feed the waste until the system uh, out the output the product. Can you explain again
Jelaskan lagi, Bang.
one more time,
Please.
please?
Okay.
Yes.
After fermentation in okay, sorry. Okay, the waste is into a chopper tube and give some water and ghee, and after the waste is sludge, the sludge goes to the machine turns waste into the first it chopper by waste into sludge, then it fermented by a temperature of 35 degrees Celsius for uh, for 48 hours. After that, the gas from the fermentation to distillation to process use of cold water. Finally, it collect the finished product in the last step. That's all.
Subham? Mr. Subham?
Yes.
Yes, it's over.
Okay. Okay. So thank you so much, jury members, and thank you so much, team. And now we will take a short bio break for 10 minutes, and let's join back again after 10 minutes after this. Okay. Let
Okay, sir. Thank you for
Thank
your
you.
attention.
Thank you, sir.
Thank you so much, team. I will start the timer now, and jury members, we will connect back again after 10 minutes. Okay.
Okay, sir.
Yeah. Thank you. Let's not disconnect it. I mean, maybe you can stay connected in the call.
Thank you.
All right, let's wait for the third jury, Mr. A, to join back again. Okay, so we have all the juries ready. So jury members, the 5 presentations are done already, and we are now remaining with the last 4 presentations. I guess it will be done in next 1 hour. So without a further delay, let me start my presentation and call our next team. Next team is Team Vaya He from Dutavakana Christian University, team ID 1500677. Team, if you are ready, you can raise your hand so that we can invite you as a panelist. It's an all girls team. All right, team, whenever you are ready with your presentation, make sure you have enabled the share sound option. Whenever you're ready, just let me know. I will stop sharing my screen and then you can unmute yourself as well. You're currently muted. We can't hear you.
Good morning, everyone. We are Team Wayahe and are proud to present to you Sri Energy, a wearable product that converts human activity into a self-sustaining power generator. This is Sri, a 20-year-old woman that hikes once every week. Even though she hikes, she's still dependent on gadgets. For example, to open maps, use flashlights, or even communicate with the loved ones. As we all know, gadgets are dependent on power. Meanwhile, there are limited access to electricity in nature. But when you have that access to energy, you will feel safe. The market that we wish to target is people just like Sri, who have the need for power when in outdoor environment. This market includes people that go on hikes, backpackers, field photographer, cyclists, etc. So this is where we started the design process using the design thinking approach. When performing an outdoor activity and our body is in motion, we have found that there is an ergonomic issue. Well, the issue is many backpacks do not have ergonomic support for the lower back. This results in lower back pain. Well, our product alleviates this issue by the placement of the device between the backpack and the lower back. This project based on a journal findings about the ergonomic aspect and the piezoelectric mechanism. To understand this, several mock-ups were designed. Mock-ups A and B were discontinued because we found that they were not optimally placed when superimposed against a 3D anatomical model. Well, coincidentally, the lower back is found to be the location that receives most vibration when the person is moving. Therefore, there is a perfect location for the piezoelectric component. To enhance our understanding of the vibration that impact the lower back, we utilize SolidWorks vibration analysis tool, which showed us the optimum positioning of the piezoelectric component. We then visualized the design in a 3D model using SolidWorks. As part of the design process in SolidWorks, we have included the 3-point belt system to provide safety for the user. You have seen the potential. Now, let's unveil the product. This is our first functional prototype, using a 2.2 kilogram density memory foam to support the ergonomic aspect. Using a ripstop nylon fabric, because it is water resistant, and 30 pieces of piezoelectric component to optimize the product efficiency. These materials are commonly available in local stores, which make this able to be produced locally. Sri Energy directly support SDG 7 by converting your kinetic energy into a clean, renewable electricity from every step. This clean power generation is our contribution to SDG 13 by cutting carbon footprints. This product also promotes SDG 3 by ergonomically encouraging an active lifestyle. Furthermore, we advance SDG 8 by empowering small and medium local enterprises throughout our manufacturing process. Ultimately, this is more than just a product. It is our sustainable commitment to both people and the planet. To realize this design, we partner with small and medium local enterprises. We have calculated the production cost in detail, which you can check through the barcode, and project an 18% cost reduction in mass production, making this product highly competitive. We believe that our product excels because it is simple, efficient, attractive, and sustainable. It seamlessly integrates technology into a wearable, solving energy and ergonomic needs for outdoor explorers without requiring any extra devices. It also utilizes wasted kinetic energy from human activity by applying scientifically proven piezoelectric technology. Our broad market appeal is strengthened by a localized supply chain that actively involves local businesses in production and logistics. Honorable jury and panelists, dependence on electricity and batteries is a real problem for everyone, especially in remote areas. Today, Sri Energy is a tangible solution that can turn this problem into an endless source of energy. We are the only ergonomic, self-sustaining power generator integrated into a personal product. Our technology is proven, our target market is also clear, and most importantly, we contribute significantly to a sustainable environment. Sri Energy, your unlimited energy solution for everyday life. Thank you so much.
All right. Team, do you have anything else to showcase, or is you're done?
Yes, we are done presenting.
Okay, thank you so much for this amazing presentation. And jury members, let's start with the Q&A. Mr. Mohammed, if you would like to go ahead.
Okay. Thank you. First, I think this is a great idea, great innovation. When the other team is speak about the machine, you came with this simple but the powerful product, I think. Now, maybe I want to ask like a quick fire question about the piezoelectric. So, team, is it will make energy if we make a movement, any movement?
Yes.
Yes.
So if I may explain it, it got the movement when the piezoelectric gets stressed. So we put the piezoelectric like on the back of our product. So it gets stressed by our backpack and it creates the energy.
Oh, so it has to be stressed.
Yes.
Okay. So my question is, if we take aside about the solution to back pain issue, because if we only focus for the energy save, maybe we don't need the shape, that big shape for back pain. Maybe what do you think if we have a smaller shape, a simple shape, like a piece of paper, we attach it in our bag, we attach it maybe in the back side of our bag. Is it possible? Just to make it more.
Yes, it is actually possible, but we are also concerning when we are using backpack, our
body lean to forward, tend to lean to forward, so we need a back support.
Which you can see through the top right picture, where our product fixed the posture from the regular person that wear backpack without and with stay energy.
Yeah, I mean that is like a back in your back body issue, isn't it?
Yes.
Yes.
I think I mean my question is, if we put aside for the back pain issue, only focus on the energy save, is it possible to make your product lighter, maybe with a small thickness? Is it possible?
Yes.
Because sorry to interrupt you, because from your maybe your first slide, you make a product based on the nice back shape of the people. I think not all the people have that beautiful shape. That's my consideration to ask. So can we make it more thinner?
If we only focus on the energy, the product can be more thinner.
Yes, it could be more thinner.
Okay, thank you, team.
Yes. Thank you.
All right, let's go ahead with Mr. Aid if you have any questions.
Okay. Miss Devina, right? Yeah, very interesting presentation. But I'm a bit disappointed because you guys don't use the full time for your presentation. It takes 8 minutes and you only use only about 6 minutes. Maybe you better to make it better, right? Now, what I want to know is, could you explain how you capture the back profile of a woman hiker, and you can convert it into geometric data in SolidWorks or CATIA or something else? That's all.
So previously, we heard that the time to presentate is around 6 to 7 minutes. So this is a new information. So I hope that clears everything. Okay.
Yes.
On the next question.
Itu sudah kita sesuaikan untuk badan.
If we look at the third picture, we already make the product to like convert human shape. It's not only for women, but it can be used by male.
Yes. So this product does not stop only for female user. It is for 18 to 40-year-old person, both female and male, and those who likes to hikes. Those are backpackers, cyclists, and other people that like to spend their time in the outdoor environment.
Thank you.
All right, Mr. Johannes, if you have any questions.
Thank you. First of all, I have to address my admiration to all of YI team. You are very understand to the energy need of young generation. I want ask you about the real world output data. Please inform to us the real world output data from field testing. I mean, do you have any data about the voltage produced by your piezoelectric? And have you test this cushion to the any kind of people? How many person have you test this discussion?
To answer that, I think we have 3 volt when it's empty and 4.2 volt when it's full. And also it needed 14 days of usage to charge the batteries until 100%. So when it's 0%, we need like 14 days to charge it until it's 100%. But why is it okay for 14 days? Because it only uses for something like emergency stuff like that.
Okay. My do you have roadmap for your products to develop this product?
We want to like create more efficient energy farming. Yeah, so we haven't got any of the roadmap because we want to optimize the product first.
Oh.
Yes.
Mhm. Okay. Do you have any roadmap? I mean, you have the first year you have planned to do something. The second year you have planned to do anything else. Something that do you already have it?
In the first time we continue, in the first time we create this prototype, right? And then in the future, we will continue year by year to develop this product to be better and better in shape, maybe thinner, maybe way more practical, maybe way more portable. And then we want to collaborate with big, small and medium enterprises, or maybe with Eager and Arai, like we know it's local. Thank you.
Okay. My last question is how do you find you and your team find the best shape match to your to match to the body?
Okay. So we use like 3D scanner and we convert it into the 3D and we style it on the 3D with a human model. So that's how we find this is the effective design for our lower back.
Okay, thank you, thank you.
Thank you. You're welcome.
All right, thank you so much, team, for this wonderful presentation. Now, I would like to request all the jury members to please evaluate this particular team via Hey 1500677. Moving ahead with our seventh presentation, I guess. The team name is Taru Prabhava, and the team ID is 1500777 from Polytechnic Caltex Rao. If the team members are present already, please raise your hand so that we can start. All right, team, whenever you are ready, you can unmute yourself and start speaking. Meanwhile, if possible, you can switch on your camera as well.
Udah itu nggak usah ini. Ini nggak usah. Di sini aja, di sini aja. Udah. Tes.
Good afternoon, ladies and gentlemen. We are the Taro Pramuat and we are proud present the project Grass-Based Paper Machine Sustainable Alternative to Wood. Next, introduce our team. I am Aldi and this is Ferdi and this Faru and this Rafi. And this my mentor, Mr. Agus Wijanto. The next, the pulp and paper industry in Indonesia was one of the causes of forest loss and carbon dioxide emissions in last year. Okay, the reason we choose this name is to create an alternative to using wood as the main material for making paper as a way to reduce deforestation and carbon emission. Okay, as I have explained it before, the use of wood as the main material for making paper has many negative impact on the environment. This is one of the reasons we are switching for the wood to grass as the raw material for paper. Well, this machine is our innovation that demonstrates how grass can be an abundant raw material for protecting tree ecosystem and significantly. Next. Product final and solution innovation. Solution and innovation propose to address the problem identified at this time. This machine also environment friendly, reducing the use of wood and hazard chemical that can lower carbon emission. In addition, this machine can be scaled for small to medium production need, making it a practical and inclusive solution.
Right. This machine is designed to produce paper using grass raw material. Our system works through several key processes: washing, chopping, wheeling, filtering, drying, and finally pressing the pulp into paper. One is washing machine. At this step, the grass is cleaned to remove any dirt or underworn material before future processing. After washing, the grass follows into conveyor and transport to cutting section. In this process, we use multi-level blade to ensure the grass is chopped finely and evenly. Next is chopper blade. Grass to boiling tank. Here we use pan heater as the heat source to boil the grass until it through into pulp. Boiling chamber. Once the boiling process is complete, the grass become a smooth pulp. It's transferred into storage tank. In this tank, we place filter system.
to spare and raw fiber the remain for the chopping process. From the storage tank, the pulp is the convert through other conveyor. Passing under heating fan, this fan help reduce the moisture content of the pulp before it entry the next stage. And finally, the factory pulp entry the heat section. In this stage, the roller press and dry the pulp until it becomes dense and from the sheet of paper. Through the sequence of process or machine can transfer ordinary grass into usable paper, providing an eco-friendly alternative to traditional wood-based paper production. Product protection. The use of local natural materials such as grass to reduce production costs and our surrounding resource by opening up business opportunities for local communities.
Next, impact of the solution. The benefit for the environment include reduced deforestation and lower carbon emission. In addition, electricity costs only 400 per year. This technology encourages the paper industry to use sustainable materials. Next, sustainability definition. One, utilizing fast-growing grass, closed water circulation system, and modular durable design, and circular economy. Next, business viability is machine. The production capacity of this machine is 1,628 for sheet per hour.
Team, 2
The
minutes left.
estimated monthly profit is approximately $3,690. With the ROI this machine for 1 year and next this video journey.
All right, team. Thank you for your presentation. Jury members, we can start with the Q&A. Mr. Johannes, if you would like to go first. You are on mute right now.
Huh? Can you hear my voice?
Yes, we can now.
Okay. As we know, there are a lot of grass type. We have gajah grass, we have mini gajah grass, steno grass, and any others grass. Yeah. What grass do you use for this machine?
Okay, sir. Maybe we will determine the type of grass that will use more specifically because in this machine we use the exciting grass in general. Okay, sir.
And my next question, have you tried the other type of grass?
No, sir. No, yeah, no. No, sir.
No, yeah. Okay, thank you. Enough for me.
Thank you, sir. Thank you, sir.
All right, Mr. Aid, if you would like to go second.
Yeah, Can you hear my voice?
Yeah,
Can you hear me?
sure.
Yeah, okay. I think this is a very useful machine. As we know, grass grows faster than tree. And I'm really impressed by the level of complexity of both process and mechanical construction. May I know why do you choose A4 size for the paper instead of A5 maybe, a little narrow one?
Yes, sir.
Yes.
Why we choose A4 sheet for the paper? Because we design this machine for compact scale to uh, for home scale, sir. We design the machine compact.
I think A5 means more compact, right?
Yes. Yes, sir. Maybe A4 common for using in this our campus, sir.
Okay, thank you.
Yes, sir.
All right. Over to you, Mr. Mohammed.
Okay, thank you. Maybe first I want to say about my feedback of this machine. Actually, I love the idea when you turn from the tree into the grass. That is a great idea. Now for the machine, I think I don't know. What is the maximum weight when you put from the washing step into the belt conveyor? What's the maximum weight? Oh, you get my point?
The in consider this 10 kilograms.
Sorry?
Sorry, sir. 5 kilogram.
5 kilograms?
Yes, sir.
Okay. Okay. My point is you have to consider when it is too light and you have that belt conveyor and that very sharp elongation from the conveyor, maybe it has a possibility that your grass will not go up. That's the first thing. And we move into the boiling, what's called the chopper blade. Maybe it's another like a safety issue because you have I think the very sharp chopper blade, and I don't know what is the height from the ground into the chopper blade. What is the height? The height?
The size chopper blade is 30 centimeter.
I'm sorry?
30
Height?
centimeter, sir.
1 meter?
30 centimeter.
30 centimeter.
In diameter.
30 centimeter only?
For the chopper blade.
From the ground? From the ground into the top of the chopper blade? I think maybe that is about 1 meter or 1 meter over than 1 meter.
For the sign. Yes.
Hmm. The height of the frame from the bottom to the top of the chopper blade. What is the height?
The height the machine is for 2 meters, sir.
2 meter?
Yes, sir.
Okay, then if it's 2 meter, I think the hand cannot reach the chopper blade. I think it's safe enough if we don't have any cover on it. Okay, and now move into from the band heater into the storage tank. So in the storage tank, we only have the like water, like liquid from the grass. Am I right?
1 meter. Is 1 meter. Yeah. Okay. Height for this tank is 1 meter, sir.
No, I don't ask about the dimension. Is the in the storage tank only the water,
In the storage tank, only liquid from the boiling chamber, sir.
Okay, actually this is my last question is like
this. Water, sir. Hot water.
Yeah, okay. My last question is this: how you transform into the water from storage tank with that range into the last stage for your machine to become the paper? How is it works? Because I ever see in the paper making from like a leaf, they has 2 stage of filterization like that. So please explain to us how you transform from storage tank, which is a water, into the paper. Thank you.
We have the nozzle to spray the liquid into conveyor in fan heater. In the fan heater, we use nozzle to spray liquid from the storage tank, sir.
Actually, I cannot hear your voice clearly, but so when it comes to water in the fan heater, directly it becomes a solid paper.
Well, sir, from this boiling tank is liquid, sir. in this uh, ventilator, this liquid change to solid vector.
Okay, okay.
All right, Mr. Reid, if you have any questions.
I already asked.
My bad, Mr. Johannes. Yes.
I already have it. No, thank you.
Okay, so all done with the jury members. Okay, perfect. So thank you so much, team, for the presentation. And moving to our eighth team, which is Team Bujang Engineer from Team ID 1500147 from College University Sultan Ajeng Tirtyasa. Meanwhile, this team is getting connected. Jury members, I request you to provide evaluation for the previous team. Anyone from Team Bujang Engineer, kindly raise your hand so that we can promote your panelist. Okay, I can see you are joining. All right, team, whenever you're ready, kindly share your presentation. Make sure you're sharing your sound if you have showcasing any videos. You can put your presentation in presentation mode.
Okay, sir. Thank you for presentation uh, time.
Click on the button to start the presentation mode. At the bottom right, you can see, just put it to big screen. Not this button. The fourth one, 1, 2, 3, 4. Yeah, the fourth one. When you select, it will put your presentation on bigger screen.
My apologies, sir. Could you repeat that?
Can you give me the remote control access, please? Yeah, so I was saying this particular button, which is this fourth one. I don't know if I can click it. Can you see at the bottom end, there are 4 buttons next to notes 1, 2, 3, and 4th. I want you to select the 4th button. Yes, perfect. Now it is working. Okay. Team, whenever you're speaking, please unmute yourself because we won't be able to hear otherwise. So Amal, if you're speaking, you are on mute.
Okay.
Okay, yeah, please start.
Hello, everyone. Today, we formally present our final design concept titled Gen Z Innovation Action for Incinerator Technology for a Superior and Inclusive Global Environment. Our project and inclusive global environment. Our project aligned with the selected theme of green energy generation, transmission, and storage. Team Bujang Engineer. Next slide. Our team is composite of 4 members. Myself, Dwi Bagistiawan, serving as the team leader, Taufik Haryadi, Muhammad Afandi, and Khairul Amal. As design engineer, we are guided by our mentor, Engineer Dedi Triawan Suprayogi, PhD, a lecturer in mechanical engineering at Universitas Sultan Ageng Tirtayasa. Slide, problem identified. The core issue we identified is the escalating plastic waste problem in Indonesia. Every year, around 6.175 million tons of plastic waste are produced nationally, with Banten Providence contribution over 33 2018 5 tons. Current waste management system like landfilling are no longer effective due to limited space and separate pollution rise. This problem not only harms the environment but also public health and urban cleanliness. Therefore, innovation and sustainable waste processing technology are urgently needed. Next, significance. Plastic waste is a global emergency that needs immediate solution. Modern incinerator technology can reduce the volume of plastic waste by up to 19%, while generating electricity from combustion heat. Furthermore, it is byproduct such as eco-vaping block, creating new economic opportunities. This approach simulated address environmental, health, and economic challenges, making it an ideal solution for sustainable development in Indonesia. Next, research spending. Our research identified 3 key aspects. First, confrontation landfills are no longer sustainable due to limited space. Second, our proposed solution integrates a modern incinerator equipped with scribe and catalytic convert to reduce harmful emission. And third, the heat from combustion can be used to generate electricity, and the residue can be transformed into eco-paving blocks. This is like final solution and innovation. Our final solution is a compact and modular incinerator that can be applied but at household and community level. The design is eco-friendly, equipped with emission control system such as with scrubber and catalytic converters. It not only reduces plastic waste by up to 19%, but also recover heat energy for green power generation. And this we make final cherry product this is marketing here.
Team, 2 minutes left.
Right. Okay. Next slide. Product design specification. Our product consistent of sturdy steel frame, a combustion chamber, a scrubber, a catalytic converter, and a control system. It operates at 18,000 to and process approximately 10 kilograms of plastic waste per bed. The system requires 2 kilowatt of electrical power and includes essential safety measures such as gas analysis and PPA requirement. The design focus on safety, efficiency, and AC maintenance, ensuring that operator can use the machine effectively with minimal training.
Team, time up.
Next slide, product detail. This slide explains how the modern incinerator works. Waste enters the combustion chamber, where it burns at high temperature with controlled oxygen supply. The heat generated produces steam to drive turbines for electricity. Exhaust gas pass through the wet scrubber and catalytic converter before being released safely. The remaining is collected as results. The system not only reduces waste volume by up to 19%, but also transform it into clean energy, a perfect example of waste to energy technology. Okay.
All right. Team, do you have anything else to showcase? Or we can, because your time is up
Yes,
already.
Product reflection.
Okay, take another 30 seconds to finish this particular slide, and then we can start with Q&A.
Okay. Product reflection. The problem of plastic waste inspired this innovation. With limited landfill capacity and high pollution rise, a sustainable alternative was needed. Our incinerator not only manages waste effectively, but also generates income by producing eco piping block and electricity. Society it creates new job opportunities and support cleaner urban environmental. This innovation contributes directly to the achievement of sustainable development goals, uh, especially this related to clean energy, decent work, and responsible consumption. Next slide. Uh, Design process, in fact of your solution. Business. From a business perspective, our incinerator is economically feasible. The product costs in around 9 million rupiah per unit, with a potential selling price of uh, 15 or 20 millions. The operational cost is low, and the payback period is less than a year. It is scalable for universities, communities, and small industries. The additional revenue from selling eco-vaping block strengthen in financial sustainability, making it a profitable green business model. Okay, thank you. Presentation.
Yes, all right. Thank you, team. Jury members, we can start for Q&A. Mr. Johannes, if you would like to go first.
Okay, thank you, Subham. My first question is, since this innovation utilize the waste and challenge the green energy generation, I want to ask you the theme about how do you ensure that your product is consistently meet the environmental safety standards, especially in varied waste composition and operating condition. Okay.
Sir, I apologize, but would you repeat your question?
Okay. Since this innovation utilize the wastes and challenge the green energy generation, how do you ensure that your product is consistently meet environmental safety standards, especially in varied waste composition and operating condition?
Okay, sir. Thank you for the question, but we would ensure our consistency by from our mentor. He gave us the standard to create this product, gave us the standard that made the energy generated is quite consistent, and we could see from the simulation itself that the product actually held enough to create the energy needed, sir. Maybe that's my answer.
Okay. My second question is, what is the expected lifespan of this incinerator component?
Okay. If the product is maintained regularly, we expected that the product could last about 20 to 30 years if there is no better product in circulation, or in the market.
How many years? 20
to 30 if maintained regularly, while also there was no better product out there in the market or in the circulation. So
Okay, thank you.
All right, moving to our second jury, Mr. Mohammed.
Okay, maybe from me, maybe there's will be more about the feedback. Okay, maybe actually your idea is great than what I think, what we just hear, but in the presentation, I think it will be better if you have one slide maybe to just more explain about every function, every sub-assembly function of your machine, so we can understand your machine work better. That's first one. And I agree with what Mr. Johannes saying. You have to consider about this temperature work, 800 to 1000 degrees Celsius is very dangerous. And if you say in your presentation it can be used as to a university or school, maybe they had to have a special place to put this machine because it will be so dangerous. But yeah, however, it is a good idea. I think it's very useful since you use you recycle the waste. Maybe my sort of my question again about the safety things. I see that in the top side there is like a door. Am I right?
Okay, so is this the top side? Which
Yeah,
side?
you have one door in the bottom box and one door in the top side. Am I right?
Yes, sir.
Okay. Actually, my question is how high is the door? I just wondering it will be reach the people can easily to open it, or because we don't have any mannequin in the 3D models.
Apologize, sir. You were asking about the height of the door. Is it correct?
Yeah.
Yes. The door from the design, the door is actually quite large. It's 50 centimeters in height.
I mean, sorry, I mean the height from the ground.
Oh, the height from the ground.
Yeah, sorry.
Thank you, sir, for the question. From the design, it's actually 1 meter from the ground to the door.
Okay. If there is 1 meter,
Dia nanya ini bisa.
Sorry? Okay, I'll continue. It is just 1 meter. Yeah, people can open it easily, but I think it's very short if that's only 1 meter for the second door. If only 1 meter, yeah, it okay, it will okay. People can easily open it, but be careful. Maybe your knees can be touch the bottom box one because it is very hard. Maybe that's my feedback. Be careful. And for the panel control panel, if the second door is just 1 meter, the control panel in the bottom it's too short. I think it's very hard to operate. Maybe that's it for me. Thank you.
All right, thank you so much, Mr. Mohammed. Mr. Ed, would you like to go?
Yeah. As we know, the incinerator operates at high temperature. Could you describe the process, how you choose the suitable wall material for your incinerator?
Team, are you going to answer?
Yes, sir. Give us a few seconds. Okay, thank you. Now, how the product works is that first we need to have the waste first, and then after that the waste is being put into the machine on the product, and said product would then we must burn the waste first, and then that waste would be transferred from the pipe into the steam turbine, in which that steam turbine would generate electricity for would be powered by the product, sir.
Yeah, it's okay. What I'm insist is how you choose the wall material for your incinerator, not the whole process. It's okay, I think. Enough, I think.
All right. Thank you so much, jury members, and thank you so much, team, for the wonderful Q&A and presentation. Moving ahead to our final theme of Indonesia Finale event, which is the team Mustache. Team ID is 150082 from Polytechnic Caltex now. So team, if you are available, please raise your hand so that we can promote to you panelist. Team, kindly raise your hands so that we can promote you. Okay. Team, whenever you are ready, you can start sharing your presentation with sound option enabled. Present the other screen, please. This is not the presenter screen right now. Can you share your other screen, team? Because we are seeing the other screen. Yes, yes, go to display settings. Go to display settings. There you can switch.
Okay, sir.
Are we seeing? This is yes. Now you can present as a screen now.
Wait. Ini apa ini? Belum. Ah, nah.
Yes, sir.
Yes, this is perfect now. Whenever you are ready, you can start speaking and we'll start the timer here. All the best.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today we will be presenting a project titled Machine for Processing Oil Palm from Vape into Handicraft. My team name, the Mostas team. My name is Fauzan Isazudi. My friend name, Haikal Zikri Damanik, and Sading Alwadar, and Zaki Hidayat. Next, my mentor, the Mr. Agus Wijanto. Okay, problem identified. Based on data from the Central Statistic Agency (BPS), Indonesia have 343 million tons of palm per year, and if not managed properly, this waste can lead to negative impact. Based on the data we collect, we begin to wonder why oil palm from front are not being utilized for something more beneficial to many people. As we know, less from are usually used by some people only as fertilizer. Therefore, we believe that palm from have the potential to be transformed into usable product. The basis of our background in choosing this title is because 1. Environmental pollution, 2. Source of disease, 3. Fire hazard potential. Next. Okay, then we selected as team sustainability habitat or city infrastructure. Why we chose this theme? We believe oil palm from front are not just a problem but an opportunity. Because since we live in Riau province, which is one of the largest oil palm producing region in Indonesia, We have observed that a significant amount of waste is generated from oil palm trees. One of these, the oil palm front. Based on our discussion, we found that this front have great potential to be transformed into a highly usable product, food plates made from oil palm front. The advantage of these platters are, first, they are made from natural materials, making them environmentally friendly. Second, once the plates are used, they do not become waste because they are biodegradable and easily decompose. Unlike conventional plates that contribute to environmental pollution and are difficult to break down. Next.
Final solution and innovation. How does we solution address the problem identified? This machine is designed to reduce the amount of waste from oil palm fronts. With this machine, oil palm fronts that have no sales value become a sales value. This machine also produces environmentally friendly product. How does we solution address the problem identified? One, eco-friendly. Reduce dependency on wood and hair chemical, resulting in lower carbon emission and a smaller environmental footprint. Two, compact and modular technology. The machine is designed to be compact, easy to operate, and deployable in rural areas and growing local communities. Three, scalable for industrial and household use, suitable for small to medium scale production, making it a practical and inclusive solution. Next.
Okay, this machine three main component, one LPG gun, two coping machine, three press machine.
First, the palm fibers are inserted into the chopping unit, where they are finally threaded. The processed fibers are then transferred into a slurry container. During the slurry preparation stage, LPG gas is used as the heat source, while a rotation shaft continuously stirs the mixtures for approximately 10 to 15 minutes to ensure even consistency. Once the slurry is ready, it is discharged through a control valve. The mold, which is the teachable, is placed on a manual table position directly beneath the outlet valve. The mold is then filled with the slurry and inserted into the forming machine to begin the pressing process. The green control is pressed after about 5 minutes. The material is perfectly molded into the desired ball shape. Once the process is complete, the red button is pressed to return the press to its initial position. Finally, the mold is opened and the finished ball might entirely from fiber is carefully removed and separated for drying or further finishing. This machine offers a practical, efficient, and environmentally friendly solution.
Team, 2 minutes left.
Next. Okay, this the simulation the machine. Okay, next. This the front plane this machine and top plane this machine.
Business viability, economic viability summary.
describe practically of your design solution to be implemented, where it will be successful. Economic capability rate. One, production capacity approximately 240 bed per hour. Market price 6 cents per flat. Hourly revenue Hourly revenue 14.4 dollar, operating cost $3. Net profit of 11.4 dollars per hour, $91 per day, $2,280 per month, and $27,360 per year. Indonesia produces over 343 million tons of palm fronds waste annually. To process all of it, approximately 331,250 machines will be required with each machine choosing around 6,450 US dollars.
Is the sample product from this machine? Suaranya.
Team, please share your presentation with the audio. Stop sharing your screen and share your screen again with the share sound option.
Hello everyone, we from the Mostat.
Yes, it's coming. Now share your screen as well.
Share bilang.
Ini jalan.
Muncul loh. Nah.
If not possible, just present your video and keep your mic near the when audio is coming so that we can hear it. The mic that you are using, just keep it next to your laptop and keep the laptop sound to maximum so that we can hear it.
Oh iya, mic-nya ada dekat. Tapi di sini nggak ada suara juga. Tim.
Ada. Tapi nggak muncul videonya.
Tidak tahu. We study at the
Hitam, Cok.
Bentar aja.
Sempat dulu. I have shared on WhatsApp as well. Please check.
Bilang harusnya mah. Op. Hello everyone, we from the Mostat team. We study at the Polytechnic Algebra. Indonesia is the world
We're not able to see the video. The video is turning black.
52 million hectares of palm plantation. Each hectare contains around 120 palm trees, and each tree produces about 22 tons per year.
Team, the video is not visible to us.
Team, go to presentation mode again.
Hello everyone, we from the Mostat team.
Yes, now it is working.
The Polytechnic Algebra. Indonesia is the world largest producer of palm oil, with over 60.82 million hectares of palm plantation. Each hectare contains around 120 palm trees, and each tree produces about 22 crowns per year. This means Indonesia generates over 343 million tons of crown waste annually. As trees, crown weighs approximately 6 kilograms. If not managed properly, this waste can pollute the environment, emit methane gas, and become a breeding ground for pest, fish, and plant disease. Other issue, we design innovation machine that transform palm pond into a co-friendly material. That machine consistent of three main parts: a starter, of pulper, the trans of material into natural pulp, and a molding unit that steps into plant and other degradable items.
Each unit costs around $6,450, bringing the total estimate investment to about $2.14 million. The machine processes one ton per unit, compressed with 80 hours per day, and has a daily capacity of 480 tons. In 1 year, a single machine can handle 172,800 tons, or about 1,336,800 kilograms of farm waste, with Indonesia producing 343.5 million tons of farm waste annually. Approximately 321,250 machines will be required to process it all.
Step process solution internally includes surrounding in adapting useful. Here's the masonry design. Let's take a closer look at how it works.
Thank you to everyone. Thank you to my lecturer, Mr. Agus Wijayanto. Thank you to all people who have always support us. We hope that your design can be beneficial for everyone.
All right. Thank you so much, team, for your amazing presentation. Let's start with our last Q&A round. Mr. Mohammed, would you like to go ahead?
Okay, thank you. Okay, team. Can I see your 3D model one more time? Just from your presentation, I can see enough what the machine work. Please, can you?
Yes, yes. This sir.
Okay. My question is actually how you transform from the what is called the blender?
No, this the mixer, sir.
How you transfer from the mixer into the mold? It's manual.
Can you reply this question?
How you transfer from the mixer into the mold?
So sir, how to transfer
make motor to molding, sir. Be manual, sir. Yeah. Manual, sir.
Manual.
Yes.
So we stop the mixer. I'm sorry, what is the behind of the mixer? What is it?
Belakang ini, meja manual. Meja manual. Meja manual untuk meletakkan
In behind mixer, sir, table.
Turntable?
Manual table, sir. Behind mixer, sir.
What is that function? Sorry.
Untuk for transfer
Izin sir, boleh mix Indonesia Inggris sir?
For me it's okay.
Jadi yang di belakang behind the mixer itu adalah meja sir. Jadi meja itu tadi tempat untuk menaruh cetakan yang akan dijadikan piring. Jadi cetakan dari piring ini akan ditaruh di meja itu sir. Jadi seandainya kalau dari molding yang tadi sudah ditaruh di pencetaknya, baru akan ditaruh di mesin pressnya sir.
Oh.
Jadi fungsinya hanya untuk menaruhkan cetakan.
Okay. So maybe my last speech, maybe my feedback is maybe you can have a lot of typical, a lot of size of the plate, and since you put to the mold is manual, you had to have a safety when you on the mold, when you on the pressure, because it will be dangerous if your hand put and you will crush your hand. Maybe that's all for me. Thank you.
Okay, thank you sir. Thank you sir.
All right, thank you, Mr. Mohammed. Mr. Johannes, would you like to go next?
Okay. Tim, what percentage of each front is usable for crafting? And how do you handle the non-usable portions?
Sorry sir, can you reply this question?
What percentage of each front is usable for crafting? And how do you handle the non-usable portion?
Jadi untuk persen yang bisa digunakan untuk piring ini tadi, kalau menurut yang sesuai dengan survei yang telah kami lakukan, itu ada beberapa material dari pelepah kelapa sawitnya sendiri yang sudah terlalu kering, sir. Jadi yang sudah terlalu kering ini sehingga serat-serat dari pelepah kelapa sawitnya sudah tidak ada lagi. Jadi kan di sini kami mengambil bagian seratnya tuh. Jadi seratnya tuh akan dari pelepah yang masih ada serat, jadi bakal dicacah, dari cacah bakal direbus. Guna perebusan nih untuk menghilangkan bakteri-bakteri yang ada di pelepah itu sendiri. Karena kan ini bakal digunakan untuk alas sebagai makanan. Jadi kami rebus yang sudah dicacah tadi, Sir.
And how do you handle the non-usable portion?
Untuk yang tidak bisa dipakai itu belum bisa diolah, Sir. Belum bisa dijadikan piring yang sesuai dengan mesin kami.
How many percentage?
20%, sir.
The non-usable portion is 20%.
Yes.
Okay. Okay, thank you.
Thank you, sir.
All right, Mr. A, if you have any questions.
Yes, last question, I think. Your machine has a very impressive concept. Could you describe to us how the first one, the chopping machine, works from the input, the blade operate, and then how the front is breakdown until it outputs to the mixer?
Yes, sir. First, sir, palm oil palm oil get in to chopper where they are finally shredded. To process fiber are then transferred into slurry containers, sir. During the slurry prepare stage, LPG gas is used as the head source, while a rotating shaft continuously stirs the mixture for approximately 10 to 5 minutes to ensure even consistency. Once the slurry is ready, it is discharged through control valve. The mold, which is detectable, is placed on a manual table position directly beneath the outlet valve. The mold is then filled with the slurry and inserted into the forming machine to begin the pressing process. The green control button is pressed after about 5 minutes. The material is perfectly molded into the desired ball shape. Once the process is complete, the red button is pressed to return the press to its initial position. Finally, the mold is opened and the finished bulk made entirely from palm frond fiber is carefully removed and separated for drying or for further finishing. This machine offers a practical, efficient, and environmentally friendly solution. That's it.
Thank you.
All right. Thank you so much, team, for the amazing presentation. And with that note, that was our last presentation. So, jury members, kindly put your evaluation score for this particular team. And with that note, we are now ending. We are on the end of this particular finale, and we would like to hear feedback from all the jury members. How was their experience about this whole virtual event? We can go one by one. Mr. Mohammed, would you like to speak something?
Is my voice clear?
Yes, it is.
Okay, maybe from me, this kind of program is very good, and maybe from this program we like to have a good engineer and with good ideas come from our country, and yeah, maybe from my side, because I'm in the field of the manufacturing of the industry, what we have for overall design of our friends, our colleges, in the colleges, maybe some of them forget about the safety things like a belt transmission that they had no cover, and for the heat machine they don't have any fences, then they don't have any plate to cover it. maybe something like that. Like in the last scheme, we need a safety button from for this molding. Yeah, I think to make our design better, yeah, beside we talk with our lecturer, our in the school or university, it will be better if we have advice from people in the field, in the uh, industries. Maybe that's all from me.
Okay, thank you so much, Mr. Mohammed, for your valuable feedback. We'll definitely work on that as well, and we would like to see what kind of changes we can integrate in our Akruti 2026 event for Indonesia as well next year. Thank you so much. Mr. Aid, would you like to go second?
Yeah, I think all of the team have tried their best. Thank you for their hard work. But I've noticed something interesting pattern that some teams with strong research foundation, I think, uh, often show less clarity in their realization. Or otherwise, the excellent modeling or detailing tend to have a weaker research depth, I think. So every participant are mastering one side of the process, but other in design execution. I think we have to go balance both of them so we can create more engineer to more realistic to industry, I think. That's all. Thank you,
Indeed,
Subha.
sir. Thank you so much. Yes, Mr. Johannes, you are the last one.
Thank you to all of team. We have 9 teams that you are all provide your best solution. I'm very happy to work with Akruti this year, and I realized that the Akruti background is very, very good to provide the real solution towards the global challenge and initiate cross-country collaboration. I hope this moment we will help other people and also to be a social engineer to provide other people in our environment to bring and build a better tomorrow. Thank you, Mr. Suban.
All right. Thank you so much, Mr. Johannes, for your valuable feedbacks, and thank you to all the juries. From my side, on behalf of Dassault Systems and Akruti Innovation Competition team, I extend my heartfelt gratitude to all the brilliant student teams who participated in today's Indonesia Finale. Your creativity, efforts, and passion for innovation truly reflects the spirit of Akruti, which we are leading right now for designing a sustainable future. A special thanks to our respected jury members for taking out time of their busy schedules to present on weekends to guide, evaluate, and inspire these young innovators. Your insights and encouragement add immense value to their learning journey. And I would also like to thank our partner, Prozinergy. I'm not sure if he is available. Rudy is available in the call. But big thanks to his entire team and the mentors or all the student teams who have supported the students throughout the journey. Your contribution has been invaluable and shaping this experience. And from our side, all the finalist teams are going to receive Akruti merchandise. The partner is already preparing your merchandise, and definitely you will receive a response from him regarding your location so that we can send it to you. And moreover, as you are the finalists of Indonesia, you will be receiving your finalist certificate soon. Moreover, you will be receiving your certification credits, which will help you in getting your professional certification in SolidWorks so that you can put it in your resume and you can enhance your professional career better. Congratulations to the participants and stay tuned for the announcement of the winners. We are going to do it in the WhatsApp group and via email. Not going to do it in this call right now. And to the winners who will be going to get shortlisted, the next round, which is AP South Geo Finale round, has been scheduled on 9th of November, which is on Sunday. You still have 2 weeks to prepare for that. And we are going to organize a briefing session for all these teams also. So the two winners from Indonesia Finale is going to compete with other teams from different countries in the AP South region, and the best three teams are going to be shortlisted, and they will be attending the Akruti International Finale event, which is happening at United States, Texas, in the month of February. So kudos to all of you and jury members. I have already organized a small meeting with all of you. If your evaluation sheets are done already, just send me over an email so that I can consolidate all the evaluation sheets together, and let's join the common meeting for 15-20 minutes, and we'll discuss the winners for this finale, and we will announce in the groups and the email ID. Okay. Thank you so much, and thank you so much, team Suraj, Komal, and Kunlik, who were there to support. And thank you so much, and bidding you a goodbye. And thank you to the teams, and we are looking forward to the announcement soon. Thank you. Bye bye.
Thank you so much,
Thank
everyone.
you.
Thank
Have a good
you.
day.
Bye bye.
Bye.
Thank you. Have a great day. Bye.